Today in this video we'll be solving problem 1 from the 2024 F equals MA test, which is a physics exam that is very basic. The problem says, an archer fires an arrow from the ground so that it passes through two hoops which are both a height h above the ground. The arrow passes through the first hoop 1 second after the arrow is launched, and through the second hoop another second later. What is the value of h? So we have this x and y chart where we can say that this is like what the arrow looks like as time goes on, where this is the y or the height, and this is simply the time or x. So in a really far distance, an archer's shot is like a curved structure, and it's saying that like 1 second after there's a hoop which it passes through, and then a second later there's a second hoop it passes through, which both have height h. So these two align, and we can mark that point h. Now, since we know that the time is 1, we can use some sort of kinematic or just physics formulas to aid us in assisting in this, as we want the distance in x between these 2 points. So we can state that, well, if we get a formula of gt squared over 2 minus velocity 0 times t plus h is 0, we can then switch these variables around to get that h equals v0 t minus gt squared over 2. For the sake of this test, they say that you want to just round the gravity to 10 meters per second, so we do that. But since we know that these occur at seconds 1 and 2, because that's what the problem says, we can then plug these values of t into this equation. So when we plug in t is equal to 1, we get that h is equal to v naught minus 5. We also get that when plugging in t is equal to 2, we get that this is 2v 0 v initial minus 5 times 4 is 20. Since these two are both expressions of the height, we can set them equal to each other, where v initial minus 5 is 2 times v initial minus 20. This becomes 15 equals v initial. If initial is 15, then that means we can plug it into one of these equations, or one of these equations, to get that h is simply equal to 10. So that is our answer for this problem.